Assalamualaikum to Dr. Wahid and all listeners. My name is Aina Najiha. I am from Group 13. Today we will present about secure hash algorithm. Before that, I will introduce my group members. So first is Nur Alisa Shadlin binti Muhammad Rafi, Nurul Ain Syafiqah, Anis Syafiqah, Aina Najiha is me, and Nur Shafawani. So we will begin with definition of secure hash algorithm. Secure hash algorithms are a family cryptographic functions that contain a set of algorithms that are built by National Institutes of Standards and Technology to keep data secure. So regarding the NIST Special Publication 856B Revision 1, a bit string of arbitrary length will be mapped to a fixed length bit string by hashing function. So these algorithms used to be one-way functions which make it impossible to convert the transformation of their respective hash values back into the original data. So first I will give the introduction about SHA. So through the Federal Information Processing Standards publication, they specifies the SHA to several algorithms. As we can see here, we have SHA-1 and SHA-224 and others. So the number in each function represents its bits values and produces different hash lengths. So all of the algorithms are one way of hashing functions that will produce message digest. Before that, however, in general, we only have two types of hashing algorithms, which is SHA-1 and SHA-2. So we go to the SHA-256. Okay, SHA-256 will convert text with any length into a fixed size string of 256 bits with 32 bytes. So the block size of SHA-256 is 512 bit, which is the amount of data that the algorithm processes in one go.
Okay, next is where is it applied? The first one is digital signatures. It is to verify the validity of a document or file. Digital signatures use asymmetric encryption. The hash algorithms like SHA-256 go a long way toward signature verification and are used in authentication and encryption protocols. Okay, the next is the password hashing. It will let the website keep user password in a hash format for two reasons as previously mentioned. It is because all the digests are the same size. It is helps to cultivate a sense of secrecy while also reducing the stress on the central database. Okay, next is SSL handshake. Okay, SSL handshake is an important part of online surfing sessions, which is to prepare a secure connection. Your web browsers and web servers must agree on encryption keys and hashing authentication. Okay, the last one is integrity checks. The file integrity has been verified using algorithms such as the SHA-256 method and the MD5 algorithm. It is ensures that files retain their full value functioning and that they have not been altered with during transport.
So for CHA-256 advantage, um, it is differs from various other common hashing algorithm because it have 256 bit key, which is substantially more secure and harder to crack. Okay, it also impossible for two separate documents have the same hash value since there are 2,256 potential hash value. And for the last one, CHA-256 does not like some of the earlier hashing algorithm where little changes to the original information will totally affect the hashing value. So we're going to talk about the disadvantage.
So basically, CHA256 performance is slower than CHA1. Okay, if we are comparing MD5 with the CHA, MD5 is speedier than CHA. Since MD5 require just 64 rounds, then CHA that need 80 iterations to complete. And the last one, CHA256 is require more space than CHA1.
Next, I will give the general explanation about CHA. So, CHA is a hashing algorithm based on MD5. So it is used to hash data and certificates. Using bitwise operations, modular additions, and compression functions, a hashing algorithm compresses the input data into a smaller form that cannot be comprehended. The process of scrambling raw data to the point that it can no longer be reproduced in its original form is known as hashing. It takes a chunk of data and runs it through a function that manipulates the plain text with math. So the hash function produces the hash value, which is the result of the hash function. The hash function is responsible to convert the plain text, which is original data, to its respective hash digest. So they are expected to be irreversible, which means your digest should not under any circumstances give you the original plain text. So hash functions, regardless of the number of repetitions, provide the same output value if the input remains unchanged.
My name is Anisha Pika and I will present about the Sudoku. Firstly, this Sudoku is about SHA-256. Firstly, we need to prepare message which is please enter data for which SHA-256 is required. Next, we'll need to compute message digest MD equal to message digest dot get instant SHA-256. Next, we will compute a byte digest equal to MD digest. Next, we need to set the string buffer SB equal to new string buffer. We will use the loop which is for byte B digest and will compute the string format. And lastly, we will generate message which is SHA-256 hash to call the output.
Okay, I will present about mathematical representation. Okay, in the picture above, we can obviously see the 64 rounds of activity that is performed on a 512-digit message. We can see that two data sources that we send in are W and K. For the initial 16 round, we further separate 512 cycle messages into 16 sections, every one of 32 digits yet. After that, we really want to compute the incentive for W at each progression, while the value of K in that multitude of rounds in pre-instated, W is one more piece of information that is determined exclusively for each block, contingent upon the quantity of emphasis being handled right now. With every cycle, the last result of the block fills in as the contribution for the following block. The whole cycle continues to rehash until you arrive at the last 512-digit block, and you then consider its result at the last hash digest. This condensation will be of the length 256 digits according to the name of this calculation. This is a detail of the algorithm's work. So for Pendy bits, uh, this is an initial step of our hashing capacity. Start with attaching pieces to our unique message. So this length will be the same to the standard length expected for the hash word. So we continue by adding not many pieces to the message that we have close by. The quantity of pieces we add is determined as such. So after the option of these pieces, the length of the message ought to be precisely 64 pieces under a variety of 412. So m plus 4 plus 64 equals to n times 412. So basically n is a length of original message and p is padded bit. So next is a length bit. We can add 60 bits of data now to make the last plain text a multiple of 412. We can assign these 64 pieces of character by applying the modulus to your unique clear text without padding. Initialize the buffer. So basically this is how buffers algorithm works. Uh, every character, for example, A, B, C, D, have their own bits, which is for 8 bits, and they will be different from the other character. So the next one is 60 different keys in array arranged from 0 to 63.
For this program implementation, we use three algorithms which are message digest, no such algorithm exception, and scanner to user input the data. In Java, we can use message digest to get a SHA-256 hashing algorithm to hash a string. Secure hash algorithm SHA-256 is a computing a condensed representation of electronic data. When a message is input to a hash algorithm, the result is an output called a message digest. A message digest range in length from 160 to 516 bits depending on the algorithm. For SHA-256, the output is fixed to 256 bits, which is 32 bytes. If we provide a non-existent algorithm, for example SHA-256, Java will throw java.security.no such algorithm exception. The capacity method of the string buffer class returns the current capacity of the buffer. The default capacity of the buffer is 16. String.format %0 to x is the easiest and obvious way to convert a byte array into a hexadecimal, which we use x small letter for lowercase hexadecimal and x capital letter for uppercase hexadecimal. As you can see for the output, we will enter the word hello world. This code will convert a byte array into hexadecimal, which include 32 bytes. To be more clear, you can see the explanation of the program implementation in this slide, which I already told you before.
For the conclusion, we can conclude that SHA-256 is by a long shot the most generally carried out in programming. Second, SHA-256 are secure and it is infeasible for an attacker to compute collision. Next, SHA-256 produces a 256 bit, which is 32 byte hash. The last one is SHA-256 will probably create an alternate hash for each unique information message. Okay, that's all from us. Thank you.